This is section 5.3, question 18. And we need to put this equation for a parabola from general form into standard form. So remember, with parabolas, we only have one variable that's squared, the other one is not. So we're going to keep the squared variable on one side. So 25x squared plus 20x, we'll keep those on one side, and then we're going to move the y value and the constant to the other side. Alright, so then to complete the square, I really want to get rid of this 25. So take that 25 out, but here's where it becomes weird. This is probably why she's asking for help with this question. So x squared plus 20 divided by 25, I'm factoring it out, right? So 25 divided by 25 is 1, and then 20 divided by 25 is, well, this reduces to 4/5. Okay, so then, here, I feel like I need to write this out so we don't get lost in what I'm doing. So we have our 4/5 x, we're going to half that, so half of 4/5 would be 2/5. So then we take 2/5 and we square it, which gives us 4/25. So we're adding that into that side, and what we add to one side, we have to add to the other side. However, because we're adding in 25 times 4/25, we're really just adding 4. Because it'll be 125 when we multiply the 25 times the 4, which is adding in 4, and that makes these numbers quite a bit happier. So 1 plus 4 is 5. Take out the negative 5, so we have y plus 1. So I kind of skipped a step here. Combine those together, that turns into 5. Oh, and I made a mistake because that would be a negative. When I factor out the negative 5 from my positive 5, I'm left with a negative 1. Okay, so we have our 25 here, and we have x squared plus 2/5. Oh, that's not squared. Square should go here. Oh, she came back. I am recording this for you.
Yeah, sorry, my phone died.
So then I'm going to divide the 25 from both sides. I see why you wanted help with this. It's a little wonky. I'm going to divide that 25 over there. All right, so we have x plus 2/5 squared equals negative 1/5 times y minus 1. So I can see the vertex pretty easily would be this number's with x, so that's h, negative 2/5, and then this number's with y, so that's k, so there's the vertex. But then we need the focal length, right? Let me read the question again. Find the vertex, the focus, and the directrix. Oh, and graph. Good heavens, this is ugly. All right, just let's find the focal length by taking our 1/5 and divide that by 4. So another way of dividing by 4 is multiplying by 1/4, which gives us 1/20. So in other words, here, I'm going to write this over here. We would have x plus 2/5 squared equals negative 4 times 1/20 times y minus 1. So that is our focal length. All right, now I'm going to start throwing this in a graph. So vertex negative 2/5, 1. So somewhere about there. And then 1/20. Okay, what direction is this one? We've got an x squared and a negative. So x squared is the one that's a function, and negative means it's upside down. So it'll be curved this way. So the focus is going to be in here, 1/20 away from that point at negative 2/5, 1. So that means that's changing the y value. So if I subtract 1/5 from 1, that leaves me with 4/5. So the vertex, we already wrote out right here. The focus will be at -2/5 because it's right on that axis of symmetry. And then it's below 1, so it's 1 minus 1/5, so 4/5. So there's our focus. And then the directrix, I know that this graph is completely wonky. The directrix is the other side of the vertex, so that would be at y equals like 6/5 because we're adding 1/5 to it. So there's our directrix, and there's sort of a graph. I guess if we wanted to, we could figure out the points at the end, the endpoints of the lattice rectum, but it doesn't ask for that, so let's not, because these are ugly numbers. I think we're good. Okay,